Welcome to our channel. In the last two sessions, we discussed the concept of single linked list. Under single linked list, what we covered? We covered insertion operation. So here we are inserting an element at three possible ways. Insert the element at the beginning of the linked list, or insert the element at the end of the linked list, or insert the element at any given position. After that, we are doing with deletion operation, means deleting an element from the linked list. Here, deletion is also performed on three different ways. Simply delete an element at the beginning of a linked list, or at the end of a linked list, or at the given position. So these are the operations that we performed on the previous two sessions. Now, in this session, we are moving into search operation on a single linked list. What is mean by search? Simply, they are given one key. You need to identify whether the key is available in the linked list or not. Suppose if the key is available, return the position or return the index of the particular element. If the key is not available, simply display one message, the key is not at all available. This is the concept of search operation. Now, what is the procedure? How we are going to implement? Assume one list is already created. If you want to do search operation, before that you must and should create a list. Otherwise, it is not possible. Some 20, 10, 15, 11, 25. Assume this is a list. What is the first node? Always the first node is pointed by head. Clear? Now, what I am doing? I given one key. The key is compared with the first node data. If matches, then answer is completed. Suppose if it does not match, now our key is compared with the next element. If it does not match, next element, it does not match, next element, here does not match, next there is known element, you need to stop the process. Now, what are the two cases? The two cases are, you are searching the key element by element. If any position, if the key is available, stop the searching. That means assume I have 100 number of elements. I am repeating a loop 100 number of times. Suppose if element is available at 50th position, now no need to do the remaining comparisons. Now, what is the second case? Suppose if the key is not at all available, that means repeat the process until end of the list. Okay, these are the two cases to comes out of the loop. Okay, you know that one. For that, what I am using flag variable. What is the purpose of the flag? On what condition we are coming out of the loop? Suppose if you are coming out of the loop because the element is available, that is one case. You are coming out of the loop because of the number of elements are completed, that is the second case. Anyway, I assume the first node as the temp node. The first node as the temp node. Now, I am repeating one loop while temp is not equal to null. Yes or no? Yes. Initially, I assume temp is equal to head. Here, temp is not equal to null. The condition is true. Whenever the condition is true, now this data is compared with key. How do you comparison? Do the comparison? If temp dot data is equal to key. If temp dot data is equal to key. Initially, I used one variable I is equal to 0. What is the purpose? To store the position. So, whenever there is a match, if there is a match, you are printing one message, your key is available at the position number I. See, initially I is equal to 0. Assume my key is equal to 20. What is temp dot data? 20. What is key? 20. Both are matched. The element is available at position number 0, right? Now, along with I am using one variable flag. Inside, I updated the flag is equal to 0 and then break. Now you got the point here. What I am doing? Whenever there is a match, no need to compare with the remaining elements. By executing the break, comes out. Suppose my key is not 20. It does not match. What happened? Move to the next element. I am incrementing I value. How do you move to the next element? Temp is equal to temp dot next. Close the while. Now tempo points to this position. Again, check the match. If there is a match, return the position break coming out of the loop. If there is no match, again temp like this. For example, if my key is equal to 11, whenever temp is at this position, it prints the data. And after coming out of the loop, you need to check if a flag is equal to 1, what is the meaning? Flag is equal to 1 means this original value is not at all updated. If it is not updated means I am not entered inside the if. If you not entered inside the if means the condition false. That means the element is not available. You got the point? So for that purpose only I am using one variable. Here I am update the variable. Based on the result of updation only I am specifying whether key is available or not. Clear? Now, I am executing the program. Before executing, I opened the program that we discussed in the last session. What's the program? Here I am creating a class. I am doing insert begin end position, delete begin, delete and delete position. All the operations are performed. Now, along with I am doing one more operation. Public void some search operation. Here you need to pass some data on which element you want to search, right? Now, do the search. What is the first step? I am assuming the first node as the temp. By default, the first node is head node. Here I marked as head as temp. Along with I used one variable. Initially, I is equal to 0, which is used for position. Now, flag is equal to 1. Basically, the first case is if head is equal to null, even though you are not writing, that's not a problem. If head is equal to null, print one message system dot out dot println list is empty. If the list is empty means no need to do the remaining operations. Yes. Now, yes. Okay. Now coming to else, what you are doing? Repeatedly do the comparison in the simple sense. Here I am following linear search operation. While temp is not equal to null. What is the temp initially? The first two element is the temp. That is head node is the temp. And if it is not equal to null, you are doing comparison. Temp dot data is equal to key. That means if the first node value is equal to the key, then what you are doing? System dot out dot println the element is available at to position I. Now, after that, what I am doing? I am updating the flag variable. What is the purpose? I entered inside the if. That is the reason for understanding whether I entered inside the if or not. For that only, I am using this one. If is also closed. Okay. Now, inside the while loop, suppose if the I condition, that is if condition fail means we need to move to the next element. So I am incrementing the I and temp is equal to temp dot next. By this statement, I move to the next position. I am moved to the next position. Once coming out of the while, you are checking if flag is equal to 1 means I am not entered inside the if. So simply system dot out dot println element is not available. I think everyone clear. So here if this is available, I am printing the value and that case if flag is if condition fail. That means only this statement or this statement, only one statement is executed. Now ob dot search of some number 30. Okay. Now you know the procedure. Save, open the command prompt. Okay. If it does not contain any error, yes, fine. Now, what is my search element 30? It is not available. Why? I delete the element 30. Here in my example, I delete the element. Anyway, observe number 20 is available. Yes, 20 is available. Go on. See, 20 available at position number 0. Yes or not? 20 is available at position number 0. Now, this is the way to do search operation in a single linked list. Along with the search operations, in the next session, we will discuss multiple operations. Suppose, how do you perform reverse operation on a single linked list? How do you find out the middle element on a single linked list? We will do multiple operations on the single linked list. Anyway, this is the end of search operation. Thank you.